Welcome to the DIY Honda Garage channel. The DTC P2122, identified as an APP Sensor A circuit low voltage issue, is significant for Honda Pilot models produced between 2016 and 2022. This diagnostic trouble code, DTC, refers to a condition where the Accelerator Pedal Position APP Sensor A, also recognized as Throttle Position TP Sensor D, does not provide the expected voltage level. Under normal circumstances, the signal should register above 0.2 volts. This problem can severely impact the engine control module's ECM ability to manage engine performance, resulting in potential drivability issues. The APP sensor's main function is to relay the position of the accelerator pedal to the ECM, allowing for the appropriate throttle input. If this sensor is malfunctioning, the vehicle may exhibit symptoms such as reduced acceleration or improper throttle response. By monitoring the circuit's voltage, the vehicle can maintain optimal performance. Hence, addressing this issue promptly is crucial for safety and functionality. The APP Sensor A, or Throttle Position Sensor D, is crucial for determining the accelerator pedal's position and consequently controlling engine power output. Located typically near the accelerator pedal assembly, this sensor provides real-time data to the engine control module, ECM. Its role is to ensure that any input from the driver is accurately interpreted, allowing the vehicle to respond appropriately in terms of speed control and throttle actuation. By monitoring the sensor's output voltage, the ECM can make informed adjustments to fuel injection and ignition timing. The APP sensor works closely with other components, like the Powertrain Control Module, PCM, to deliver a smooth driving experience. If the voltage drops below 0.2 volts, it triggers DTC P2122, indicating a malfunction that needs immediate attention. The first potential cause for DTC P2122 is a malfunction in the APP sensor itself. If the sensor fails or becomes faulty, it cannot provide accurate voltage signals to the ECM, resulting in performance issues. Another common issue involves wiring problems. Loose or damaged wires can inhibit proper voltage transmission between the sensor and the ECM. It's also possible that an internal failure in the Powertrain Control Module, PCM, is affecting the communication with the APP sensor. Each of these components plays a critical role in maintaining vehicle performance, and any failure can result in the DTC being triggered. Further investigation is essential to narrow down the root cause and ensure proper repairs are made. When DTC P2122 is active, drivers may notice several symptoms affecting vehicle performance. One prevalent symptom is poor acceleration. The vehicle may respond sluggishly or fail to reach desired speeds. Additionally, abnormal throttle response can occur, making it difficult for the driver to modulate speed effectively. The check engine light may illuminate on the dashboard, alerting the driver to a potential underlying issue. In some cases, the vehicle may enter a limp mode to protect the engine from potential damage, further impacting drivability. Recognizing these symptoms can be vital for early diagnosis and repair, thereby restoring normal functionality in the vehicle. In the first troubleshooting step, you begin with turning the vehicle to the on mode, ensuring all electrical systems are operational without starting the engine. Connect a Honda Diagnostic System, HDS, tool to monitor the APP sensor's output voltage. The threshold value to look for is less than 0.2 volts. If the current condition does indeed match this threshold, it indicates a confirmed fault with the sensor or its circuit. If the readings show normal voltage, the issue may be intermittent, suggesting a need for investigating poor connections or loose terminals at both the APP sensor and the PCM. This first step is crucial in determining whether the error is consistent or if it requires further diagnostics under specific vehicle conditions. For the second step, ensure that the vehicle is turned off before you proceed to disconnect the APP sensor 6P connector. This precaution helps prevent electrical shorting while you work. Once the connector is safely disconnected, turn the vehicle back to the on mode to conduct a voltage test. You will measure the voltage between test points, specifically between pin number 4 and pin number 5 of the APP sensor 6P connector. Ideal conditions will show a voltage close to 5.0 volts. If this voltage is present, it indicates that the VCC3 line, which provides power to the APP sensor, is functioning correctly, allowing you to move on to the next troubleshooting step. If the voltage is absent, it suggests a problem that requires further investigation related to wiring or connections. In the third step, turn the vehicle off and proceed to set up for continuity testing. This involves jumping the SCS line using the HDS. This SCS short will help ensure that you are in a mode suitable for diagnosing issues. After waiting for more than 1 minute, disconnect the PCM connector A, which has 51 pins. With both the APP sensor 6P connector and the PCM connector disconnected, you'll want to check for continuity between pin number 6 of the APP sensor connector and a solid body ground. Conducting this test when the vehicle is off helps prevent any risk of electrical interference or shorting. If continuity is confirmed, it indicates a short in the AP1 wire that must be repaired to restore normal function. If not, you can confidently move to the next step in troubleshooting. Proceeding to the fourth step involves preparing to check for an open wire in the AP1 line. You'll connect a jumper wire between terminals A, which is pin number 6 of the APP sensor connector, and terminal B, which connects to body ground. This action allows you to create a direct path to check continuity effectively. With the system in off mode, examine for continuity between pin number 45 of the PCM connector A and body ground. If continuity is confirmed, it implies that the AP1 wire is intact and you can proceed to the following step. Conversely, if there is no continuity, it indicates an open circuit that needs to be repaired along the wire path connecting the PCM A45 to the APP sensor. In this step, it's essential to remove the jumper wire you set up in the previous step to ensure proper system operation. After removing it, reconnect the PCM connector A. You will then need to create another jumper between pin number 4 and pin number 6 of the APP sensor 6P connector. With these connections finalized, turn the vehicle back to the on mode and use the HDS tool to check the APP sensor output voltage again. As previously stated, the sensor should register values less than 0.2 volts if there are still issues. If this condition holds true, you may need to look for authorized service information concerning the DTC or consider substituting a known good PCN for testing. If the signal appears normal, you might need to replace the APP sensor itself to rectify the problem. As you follow up with the sixth and final troubleshooting step, begin by turning the vehicle off and preparing for a continuity check on the VCC3 line. First, jump the SCS line with the HDS and wait for a bit to stabilize the electrical systems. Next, disconnect the PCM connector A again to maintain a safe working environment. With the VCC3 wire in focus, jump between pin number 4 in the APP sensor 6P connector and body ground. Check for continuity between pin number 41 of the PCM connector A and body ground to verify the integrity of the VCC3 line. A positive continuity result signifies the wiring is in good shape, and you'll want to check for more information regarding DTCs or possibly substituting the PCM if problems persist. If continuity fails, this indicates an open in the VCC3 wire that should be repaired accordingly to restore proper function. After completing the necessary repairs related to DTC P2122, it's crucial to verify that everything is functioning correctly. Begin this verification process by confirming that the repairs made have effectively resolved the issue. Clear the DTC from the vehicle system using the HDS effectively. Once cleared, perform a thorough test drive under various conditions to ascertain that no symptoms reappear and that the vehicle responds normally during acceleration and throttle input. During this test drive, pay special attention to any signs that could suggest lingering problems, such as erratic throttle response or the activation of the check engine light. This verification process is essential to ensure that all systems are operating well and that the driver can safely operate the vehicle without further concerns about performance. To prevent the reoccurrence of DTC P2122 and to ensure your vehicle operates smoothly, practice regular preventive maintenance. First, make it a point to routinely inspect the wiring harnesses and connectors associated with the APP sensor and PCM. Look for any signs of wear, corrosion, or loose connections that may compromise performance. Additionally, periodically check the APP sensor's functionality as part of your routine vehicle maintenance. Checking voltage outputs and operational response can catch issues before they manifest as trouble codes. Staying updated with any service bulletins or recalls related to the throttle position sensors can also be beneficial. This proactive approach will help maintain your vehicle's performance and reliability, reducing unexpected repairs in the long run. In conclusion, understanding DTC P2122 and its implications is vital for maintaining proper vehicle performance in the Honda Pilot models from 2016 to 2022. By following the detailed troubleshooting steps outlined, you can effectively pinpoint the root cause of the APP sensor circuit low voltage issues. Each step is geared toward methodically assessing not just the APP sensor, but also the wiring and PCM to ensure comprehensive diagnostics. Moreover, implementing preventive measures, such as regular inspections and staying informed about service updates, will safeguard against future issues. Staying proactive with these procedures not only enhances vehicle reliability, but also contributes to a safer and more enjoyable driving experience. Please like and subscribe to the channel. See you next time.